Hello civil engineers, welcome to my channel. In this video, I will show you how to model and analyze and design real-life structures or buildings in Staadpro Connect. Okay, so sorry for this. I have opened my new model here. I have created a new model, so there are several ways to model, but I prefer using the nodes. So I will show you how. So I have a architectural drawing here. So I will copy. I want to copy the first floor, which will be one down here. Copy somewhere there. Okay. Then escape. Then from here I can tell that the distance between. I need first of all to make sure that the units are in millimeters. So I'll go to DWG units, then enter, 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 enter. Then escape it. So my units are now in millimeters. Then I know that the distance between the edge of this beam here and the edge of this beam here is 8,200. So I can say that this grid is, because the beam is 200 millimeters wide, this grid is on the center, so it is plus 100 plus 100, so 8,200. So we need to measure this distance to be able to scale. From there, to, so the first thing is to make sure that the units are in millimeters, then you scale. I need to find the distance, so we use the line, then snap 90 degrees, then intersection. So from here, go up to here. Then hold Control, enter. Then drag it down. So to find the scale, we will divide 8,200 divided by this. So calculator, $8,000 plus 100 plus 8,200 over 57.4001. Then is equals. So this here is my scale. I will copy the scale. Then I will select my object. Then remove that one. Then scale. Then my base point will be there. Then I will just paste the scale. Then hit enter. Now you can see that the distance there is now 8199.9. So when you round off, it's approximately 8,200. Okay, so I will change the dim style, dimension style. New. No, modify. Round off 0, it should be. Then text height can be approximately this times 4.572 times the scale. So the scale was 142 times 5. That's approximately 550. So 550. Then symbol also can be around there, 550. Then primary unit, then okay, then close. So now you can see that we have scaled the dimension style. Now we also, when you scale the dimension style, you also use the scale which you applied. Okay, so it's now 8,200. So now we can turn off some layers, and then we can now measure our self. Okay, so turn off some layers. I will turn off this layer, then okay, that's all. Then I will delete some then I can select this, select similar, let me see. We need to delete some things, okay? So we can delete those. Okay, delete. Now we can measure ourselves. We can measure the so this grid, see, just there. Wait, so nearest. Escape it. Sign, I don't know what is the problem. Then drag it up. So I just use that one. Then nearest. Then now about 90 degrees, hold control key. Then there. Okay. So and then can come to annotate from here, continue there. Then continue. And continue. Then continue. Then continue. And continue. Wait. First of all, you can see I need to remove this one or take it somewhere. You can see the scale. You can see how it was, reduced by that scale. So, and move it. Just move this away. Move it down there. Okay. And then I will come annotate, continue with my dimensions. Okay. Wait. And just continue my dimensions and see distances. Okay, so now measure the distance from there here, then snap, then you can hold control because it can move away, measure other length. Possibly that was the reason we found 89, 29, 80, because I believe this one should be 900. Let me check. Continue. Let's finish here. Let's finish. So up to here. Okay. Then go up to here. Then go up to here with this beam. Then go up to here. Then go up to here. No, because you can see this one is not touching this grid, so it is not accurate. So I can just come and then you do this first, and then make sure it is 900 because yeah, I can see it is 900. Then we continue. So this one we are doing real life, so actually what they do on site. Okay, so you need to unsnap this. We can just do that up to there, then delete it. Okay, then you can have a chance to select another point. So select this, then continue. Okay, then we continue. Oops, not there. Sorry for that. So continue, just touch there, then we move up to this grid. Okay. And then up to there, and then up to there. So you can see those distance. So I also need to measure this side. Okay. So first of all, let me check this side. So 31, 30. So for me, I don't prefer to, like, if you can look at this structure carefully, you can see because this is a void. This is basically a void. There is nothing here. Let me delete this. you can see that there is like symmetry. If you have a mirror, you have a midpoint here. You find there can be two sides which are similar. And this is this side and this side. So me, for this type of structure, I would not design. I would not prefer to to do the entire. I would prefer to model and analyze and design halfway, and then I will use the same design for the other side, because it will really make my work fast, and also it will make me more accurate, because I have less, I have a smaller area to design and analyze, so I'll be more accurate and I'll be actually even more faster. So what I need to do to have symmetry, I can, let's say, let me check, annotate for this one here. Let me make it 30-50. So I can just come from there. So I just 30-50. So this one I will increase it. Properties, height, make it 300 or 400. That's okay. So this one here, let me move it down. Make it 30-50. I will move this now. And also, so that 50, I will carry it to, it's already 30-50. Okay. Uh, 50. This one, mine will be 30-50. This one, 30-50. So that one is okay. Then this one will be 31 or 5, 3,000. So 3,000. Actually, I can make this one 3,000 also. So, but you don't just do things on your own. You ask for architecture, because from a structural engineer point of view, you don't need to design the entire structure. Okay. So from a structural engineer point of view, you need to have this dimension, similar on those sides and this side. Because even if these stairs, you can see these stairs, you will find that they are also not equal in terms of dimension. Okay. So for this, I want it to be 30-50. So I will change the annotation here. I'll go to annotation. I will click manage new style, and then I will add div, then area bold, and then okay, and then it will be area but bold. Apply, close. So I will come here, select this properties, style will be area bold, then can move it. Move it there. So you should ask for specifications from the architecture. You should like request for more information. So because there need to be that collaboration between the structural engineer and the architecture. So for me, this one I will make it 30-50. Move. Okay. This one is 3050. So I will carry the 50 up here. It will also be 3050. So that 50 and then 3000 is okay. But 100 here. No, that 100 that 50. So I match this property with this. Then that is 50, that is 50. So this one should also be that 50 because I need symmetry. So that is 50, 300, 3000, that is 50, that is 50, 3000, that is 50, that is 50, 3000, that is 50. So that's how I will model my my structure. So I don't need to model the whole structure. I need to model it halfway. Let me copy this and put it somewhere there. Copy. Then I copy it, so that move it and do. Escape. Then, so what I need to do is to show you how I will model this structure. So I will come to this point. So polyline. Then I want to show you the two similar objects in terms of shape, that I will just model one and then use the same design for the other. Then let's just close the polyline. Okay. Then I will select it. I want to select this one and see. So you can see there's another similar similar in shape to this shape in this down side. So I will need to just design this, and then I will use the same design to the other part. And so I will design this and this. So for the other part, I will use the same design as this, a similar design. So if it was like a rectangle, we just need to divide it in the center, or even if you can just do a quarter, okay, as long as the other three are same in shape, okay, so they will be same in design. So I can just now delete now the upper portion, okay. So I will delete the upper portion from just come and copy, select those, then delete. So I hope it makes sense to you. So here I just put a line XL, just wait, XL H, then I put this line there, then trim, then I select the line, then I will trim the upper side. So you cannot trim some part because I can just do it from there. Select similar. Okay. Then we can just continue. And just maybe join. Then escape. So we will now measure from this side. Remember, this side there is some difference. So just come, then snap it, then hold Control. From there, then up to this part. Not sure. From here, and go up to there. So 600, and then continuation. So I need this beam to be here. I don't need the beam to be in a different place. To there. Okay. Then so select similar. Then I need to extend, maybe extend. Just do that. And I think actually there's an issue because this grid here is not where it's supposed to be. So let me redo the grids. XL, V. So this grid just there. Oh no, oops. There. Yeah. There. Yeah. 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 Then yeah. You need to delete the first, the second one, and delete. Okay. Now you can see there was something wrong here. So XF H. No. So you can just continue with the horizontal ones. Then we go back to the vertical and correct wherever there is anything wrong. There. So that one there is something wrong. It did not touch. There. Yeah. Okay. So we need to delete some unnecessary grids. Maybe there is one which went the wrong way. Delete that. Okay. This one also went not the way we want it. This one should be not here, but here. Okay, where we are having this beam. So exit then vertical, then nearest to that. Oops. There. So we need to delete this. Then you need to redo the measurement. So I'm going to delete that, and I'm going to delete those. So I'm going to come continuous. So first of all, I will continue up to there. Then I will delete it so that because it is snapped to that. And I come here, and now I touch this, and we go up to nearest there. Yeah. No, actually, I think here is also another place you should request for more information from the architecture. For me, I think this beam was also supposed to be here and not here. That's why there is confusion. It's not supposed to be here. There's confusion. I will just move it. So you should always be communicating in whatever architecture you're working with. So there should be there. So this line also should be moved from there to there. So it should be the way it was. That's the way. Okay. Then I will draw a triangle. First escape. That one is going to. My laptop is a bit then select it, then trim, then trim, then trim, and trim, then delete. Skip it. First of all, we need to delete. There are two grids here. Delete this grid. Then I need to delete out one. So that is it. So there are several ways to model, and remember, we have decided that we are changing this distance. So based on the more information that we have requested from the architecture, so I've decided to use here 350, not because I need symmetry in the structure. I'll use 3050, and I also don't need to increase. If I increase the size of the building and maybe there is no space, it should be just at least same or at least just a bit, but based on how you agreed with your architecture. Okay. So we are going to we are going to name these grids. So annotation, I'll do single, yeah, and there, and there. So I put 0, 0, and then I will select it, escape, select it, properties, rotation, my rotation should be 0, okay, rotation should be 0, and then properties again, it's too big, my height, I'll put it 400, or then properties, my height be 650. So I want to put the coordinates, and remember this is x and this is not y, this is z. So x is basically the distance going this way, and y and z is the distance going this way. This is the z direction, this is the x direction. So I will move this one, move from here, first of all escape, move from here, then I'll move this snap, make decrease, that's my 0, 0. Then I will copy this, copy from there. Now remember, my x is not changing, only my z is changing. So 0 is 0, then this one is we will change it later, okay. There we will edit the z. So then there, then escape. Then here should be a summation of the 3. So calculator, escape, calculator, 30, 50 plus 3000, that will be the z, plus 30, 50, then equal sign. So this one is 0, and then 90, 100. That is x, z. Then this one is 0, then we can add plus 24. $20, 24 or 5. 0 and 11, 5 or 5. Then this one is 0 plus 5600. You can see the distance there. 50, 56, 0, 0. 0 and 17, 1, 17, 105. Okay. Then we just put the opening and closing, and do the same here because they are coordinates. Do the same thing here. We'll do the same thing here. Okay. Then we will go now to this side because you can see obviously these distances are different. Okay, so I will need to add another grid for this. So for this beam XL, escape it, and just put the opening and closing. Closing, then escape it, then escape it. Then I'll copy this. Now this one Z will be 0. Then the only thing that will change is X. Copy, and I'll copy from here. Then there. Okay. So I'll put this X. I want to add this grid for this beam. Then escape. Then the only thing that is changing here is the X. So X is this plus this plus this plus this plus that plus that plus that. So it will be 2900 plus 4200 plus 40,000 plus 3990 plus 1700 plus 5600. Then enter. Then the value is so this 9,000 is not supposed to be there. Okay, so it is 2900 plus 4,200 plus 4,000 plus 4,210 plus 3,990 plus 1,700 plus 5600 then is equals so 26. That is it. So I'm gonna come here and in my X I will change here to be that value. Then control paste. Then we can just copy this and then change the Z direction. And so that I don't get confused, I will delete this one or edit it. Just edit it. Fix my value. Just put 0, 30, 50. But I will not get confused when I'm. Then this one I also edit. Then I'll put 30, 50. And delete and also where else? So yeah, I will not get confused now. That is 50, 3,000, 3,000, that 50, that 50, 3,000, that 50. So I can now be able to just delete this one and this one, then just fill in my Z. Here the first will be 30, 50. Here the second will be 60, 50. That one will be okay. 60, 50, 60, 50 plus 30, 50, 9100, 9100. The other one will be plus that 50 will be just equals I think it should be 12 150. Calculator. That is 150 plus 3000 should be 15. 150. Okay, then plus the last one 30, 50. $18,200. Now I can just copy this and put it there, and then the value will still be the same. Wait, somewhere something we did wrong. It was up to there we were okay. So there's something we did wrong. I think something we did wrong because this one here is bringing confusing. So copy, paste it again, copy. This one should be 18,200. So, and then this one, copy. We copy it here. The only thing that will change now is the x, which will be 0. So remember, this distance up to here should be the same with this distance up to here. So up to the last is just the same as 18,200. So not 17. So I'm going to delete this. Okay. And now the distance from this one, this point to this point is now minus 5600 in the z direction. So I will copy and put it here. So this is remember this is 0. This is 0. X is 0 here. And X is minus 5600. So it will be 18200 minus 5600. Minus 5600. So total of 600. Okay. So this one here will be total of 600. Then we also copy it up and subtract we copy it here, there, and then there. So we will subtract first 1700 minus 1700. So this point will be 90 or 10 900. Okay, 10 900. Then this one will be 1000 minus 20 or 4 minus 24 or 5. Minus, so it will be 84 95. Okay, so I'm done. And then the topmost part is this. The first point is still 0 0. Okay, I hit escape. Now I can just copy this all the way up to here. Now remember, the only thing I will be changing here is the X. So I just copy everything, copy, and put it here. There. And some I'll put down, some I'll put on top, because when I go to add, there will be there, here. Okay, so this one I move it down. Okay, so the only thing I now change is this will be to 900. Then here will be 2900 plus 4200. Okay. Calculator again. Escape it, calculator. 2900 plus 4200. 7100. So this will be 7100. Then we will also plus 100 plus 4000. Okay, plus 4000, 11100, 11100, and then plus 42 plus 4210, 15310, 310. Okay, then down here 310 plus 990 plus 3990, 19300, then here plus 1700, 2100. Then we add 56, it will be of course 2600. So what I'm gonna need to do here is for me just to carry all these up here, carry this, copy this up there, and then I will change. Okay, I will change the Z direction to be now 12,600. I'll just move like that. And escape it. This one was 2100. I don't know. 2100. Maybe I didn't. Okay. 21,000. Actually, not 2100. Escape it. And then so here I will change it to be 21,000, and then this one I will change it to be 150. As you can see, there's a direction from here. Okay, so the rest will be just, all of them will be let me just move this just a bit up. Just move it there. Move. Yes. There. And then move down there. Move down there. Then other than there is okay. And this one for this point, I'll just move there. Okay, so I just come and change the X, the Z into Z direction to 12,600, all of them. Yes, I can just copy that and paste. 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 Then paste. Then I also need this. I also need the top, this here. So just copy everything again from here, here, then copy, and I'm gonna move it straight up. Up there and escape it. Then I will only change now to 1060. 10,600, not 60. 10,900. 10,900. Then I will copy and I will paste it. Paste. Paste. paste, and then and paste. Okay, then because of the congestion, I can just move this one down here. So these are all the grids I will need. Okay, so I'll measure the distance from this. I also need this grid here. Let me measure the distance from here to here. So measure. Escape first, then I'll snap it at 90, then hold the control, then okay, from there no, I don't need that. I did hit this point. Then this point to this point, it should be 58 something. So based on how you have communicated or requested for more information, RIF from the architecture, you'll be able to know exactly what this distance should be. So if we subtract, you can see that the distance is that one 5800 up to here, then 4100 up to here. So for me, I will use 4100 based on how I've communicated with my architecture. So yes, so you can just copy this. Just copy this to there and to there. So this one here. So I just need to reduce the size of all of this. Select similar properties. So I just need to make it around 400. 400 is okay. And it's too big, so that everything can be able now to fit. So this one is for this point. Move. Okay. Move up here. And this one, I'm gonna move down here. Now, copy this, move, copy, and copy here, and copy. Yeah. No, I don't need to snap anything, so I just move all these knobs, then escape it, then I will move this on top, move 90 degrees. Now here is only the X that is changing. So this one I can just move it be to the other side. There. So here now it will be 4100. Escape it. 4100. Then here will be 5800. In X direction. Now the same beam applies on the upper side. So I just copy the two of them, put them here. So the only thing I will change is now the Z direction will be 8495. Okay. Now we are not done yet, so unfortunately, so I need to do also these ones. Okay, I need to copy these ones. Now we change. I will now subtract in the X direction. Copy, and from there, then from there, then escape it. Then I will just subtract here 5600, which would be, they will all be 2100. Okay, then copy, then paste, and paste, then paste. Oops. Then paste, then paste. Then here will be 19,300. Remember, the units are also very important. They are in millimeter, not meters. Paste, then paste, then paste, and paste. Now I've done all my grids. So what I've left to is I might need another beam somewhere. I might need another beam from this point to this point. So I just copy this, then copy, then do it there, then change the here to be 2100, 21,000 actually, 21,000. And then do I need another beam somewhere? Another beam here, then that beam, so it's okay. So yeah, that is it. So next step is to now open my Excel. Then I will just put all my grid there in my Excel. So remember, it is X, Y, and Z, and then nodes. So node X, Y, Z. Okay. So node, this one will be node. Then we just use this number and then assume here to be where one is starting. X, Y, Z. We can just put the numbers here 1, 2, 3, then select the 3 and continue. No need of assume, just need to be sure 100%. Okay. So the next thing I will come to my and I'm just trying to move this that way and try to use that one and expand this one. Then I will put it. I put all the nodes in this direction from here, like that. Okay. So just make sure I move. Then I start with any, as long as we will not miss anything out. So 26, 600, actually this one should be 19 if I'm right. Okay, this one should be 19. $19,300. So let me just save this for the case, because Autocad sometimes will crash. Sample and save. So there we start from maybe 19,300, and all y will be 0, so z will be then 0, z will also be 0 for that, so all y will be 0 up to the last, because it is x and z. So 21, 0, 0, 21,000, 21,000, 0, 26, 600, 26,600, then 0. Then go to the next. You can just start with, you can just even decide to start with this x, go this way, or start this way, go that way, it doesn't matter. So this go 19, 300, 30, 50. 21,000, not 50. 26,600. Then here you can just Okay. So here we go 19, 300, 20, and then 60,000, 6,050, then 21,000, sorry, 1,000, then I don't know, put that negative sign there, 1,000, 21,000, then 26,600. Then adjust to there. Go to the next one, this one. The next one is actually right here on top. Okay. Now this one will be 0, then 84, 95. And then this one will be 100, 4,100. Then this one will be 5,800. So, but remember, you should always be in communication with your architecture to request for more information. So the next one is this now. 19,300, 9,100. $21,000, 26,600. Then okay. Then we go to this one, 0, 10,900, then 4,100, and then 5,800, and then we are missing this, the lower parts, 2,900. Doesn't matter the order. 7,100. Then 1,000. 1,100. 11,100. And then 15,310, and then 19,300. So I think we are done up to here. I think there are 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So they are okay. So we come here, then just drag. Then we come, the next should be this. $21,000, and then 12,150, and then 26,600. And then 12,000, and just drag it. Okay. So the next one is this one, okay. So which is 0, 12,600. Then 29, 2,900, and then 7,100. And then 11,100, and then 15,300, then 19,300. Then we will make sure, I think there's also 21,000. Okay, so we make sure 1, 2, 3, 4, 5, 6, 7. So we are 1, 2, 3, 4, 5, 6, 7. So I just drag this. Okay. Now we go to this one. This one I think we didn't add something missing. So just carry this, copy, then copy, and then put it here. Okay, and escape. And the only thing that is changing here is the x direction will be now 21,000. 21,000. So here will be, then here will be 21,000. Then and then 15, 1,150. Then 26,600. Then just drag this. The last thing will be now this 0, 18,200. Then 29, 2,900. Then 7,100. And then 1,000. 11,100, then 15,300, then 19,300. Oops, 310 actually. 15,000. All 50,000 is 310. If anyone has noticed that, sorry, 10. Can be probably most likely only 3 times. Yeah, 2,310. And 10. So there are only 3. I'm saying here, okay. And then 21,000. And then actually 19,300. 19,300. Then 21,000. 21,000. And then 26,000. Uh, 600. So I just drag this. And then we make sure they are all of the 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this last one, I'm going just to delete it. Entire row. Okay. Now you can save this. Save. Now the other thing, if you come here, you can see our X, Y, and Z are in meter. Okay, they are in meters, and we have provided here in millimeters. So don't forget that. So just come, copy everything, paste, then 1, 2, 3 up to 42. Then just drag up to 42. Then this one should be this one should be equals to this divided by 1000. So, and then drag this downwards up to here. This one should be equals to this, and then drag it. Then this one should be equals to this one divided by 1000, and then drag it. Then copy this table. Oh, wait. Copy. Then paste. So we are going to copy the coordinates here. We're going to copy paste. Then we have our coordinates. So you can go to view and then put that view, and then back to geometry and add our views. Remember, you can do this. You can just drag up to the end, and then you will break the beams and the nodes later. So I will show you. So I can just come and select node cursor, then I'll select the nodes, then hold control, then I select all those nodes, then come back to the geometry, and then I will click there, break beams or divide beams that pass through selected nodes. So 14 new beams created. So if I come to select beams, you can see my beams are separate. Right, so we need to add our beams. You know why we should break them? Because we don't need very long beams. So this one also should break it. So select beam cursor, and I select and see that beam, should break it. Now this beam, I should break it at this node goes. So actually I will delete this. Okay. Now delete this. Okay. Then I will add the beam there. Then there. Add there. Then I will select the nodes. And then I will break. So go and select node beam cursor. You can see. Now I will select all my columns. So you can see from this the position of my columns. You can see I have column here, I have column here, I have column here, I have a column here, I have a column here, here, and then here, here. So basically this is the hatched one. Mean there's a wall. So there's a beam and a wall and a column, the wall, then the kitchen, and then now beam without wall, but column, then there's this column here. So this column is holding this is the balcony. This column is holding a balcony. So there's no column here, but there's a column there. So you can see it. And there's a column here. There's a column here. And then there's a column here for the stairs and here. Yeah. So that is a column at this point, as it is at this point. So even if the architecture did not include, from the structural point of view, you need a column here and there and there, because we know that the spacing between columns should be at least not more than should be at least should be less than 6 meters. So we need a column. So this is about 3. So we need a column there. You can see this about 5.6. So select all my nodes in the column, and then I'll do transitional repeat. Node cursor. Select that. And select that. There's a column there, there's a column there. There's a column there. All these are columns. Yeah. Okay, there's a column there. And do transitional repeat. The left hand. No, we don't have a column here. No column here. No column here. No column here. So transitional repeat. Why? So first of all, negative 1.2 for our foundation, and then we leave the point. Okay. And then story height is 2.85, then 4 times, because we have it's G plus 3 floors, then link steps in the right direction, and then okay. Then I will come to 3D view. Then I will select all my beams parallel to X, parallel to Z, then transition repeat Y, then 2.85, and then 4 steps. Then okay, don't click step first, and then we delete the plinth beam because in this building there is no plinth beam, so we delete that. So just click because it's already selected. Wait, there's a beam missing, so go back to plane view. So I can go to side view, then I'll select that floor, and select beam cursor, and then I'll select this floor, then view, select objects value, and then remember there's a beam here below this balcony, gives a beam, so beam there, beam there, beam there. Then first of all I will delete the selected one. Okay. Yes, no problem. Then I'll select this beam. And I'll do transition repeat. So repeat along Y, then 2.85, then 4 steps, then okay. Then I will delete the selected one because you don't need to blink. Then I will go to RCDC. Then I will do the entire structure. That's how it's looking. Then I'll come and select this node, this beam, that beam, that, and do transition repeat. Because this is for right angle. Transition repeat along Y, and then 1, then 2.85, 1 step, then I link steps, and then okay. You can see my water tank. From there, we're going to add our properties. Now, from here, from the way I do with my architecture, we have circular columns here, holding the balcony, and then the rest are rectangular columns. So, I will add my circular columns. I will define my circular column is 0.3 meters. Remember, don't forget to check the units. Units are very important. And then I select all my column, my circular columns. So I'll go to view. So I'll select that is the position of my circular columns, and then I will do selected units. Then I'll go to 3D. Then I will select, because I will select units parallel to Y. Then I will assign to selector. Yes. So I'll assign circular 300 millimeter diameter. So and then I'll close. Then I'll go to view. I'll view the whole structure and then plan view. And then go back to material. I'll define the material. Zero point 25 rectangle. Now rectangular. I need 0.25 into 0.35. Then I will add. Then remember it is literally 0.25 to 0.35, so very easy. So I will select all my columns. So select all these. Look at the position of my columns, and then I will select it on 3D. Then I will select parallel to Y. Then I will assign. So you can check 3D so that we know the directions. We have not done vice versa. But you can see the longer side is this, so this 0.35 and this 0.25, so it's okay. So this is the whole structure. Again, we'll go to plan view, then we'll define new rectangular. Now 0.35, 0.25, then I'll add. Then now I select the ones on this side. So select this structure, the entire of it. Then we selected one. Then go to 3D. Then I will select parallel to Y. Then I will assign. Yes. Then I can check 3D. So we are okay, 0.35, 0.25. Then I will do the whole structure. Go to plan view. Then I will select my water tank. So remember water tank. This is only not only the stairs but the water tank. So the heat of the feed should be a bit bigger in the measurements. So selected one, 3D, and select parallel to Y. So then I will define new. This time 24. Do 0.225 or 0.5. So 225 to avoid the extensions. So and then select parallel to Y. Then I will assign. Yes. Now I will define my beams. My beams are rectangular point. Now point 2, then 0.45. Then I will add. Then I will close this. And I will view the entire structure. And I'll select all beams parallel to the X and Z. And I will assign. Yes. So let me first go to view. First no. And go to view. Make sure will not select columns, then assign pages. Then I can go to 3D rendering. Let me see. Now I've made a mistake here, because you can see this one now should be the other way around, because you can see it should be. I can now go to this and edit. Now this one now is the one which is 0.45. Then this one is 0.2. Okay, then change. And then again 3D. Now it's okay, you can see the beams look like in 3 dimensions. That's why I was doing so. You check the rendering. Then go to now the whole structure. The whole structure will look like. Now go back to geometry. I'll select this. So I'll use selected objects only. I'll go to that view. Then I will add my plates. There. Okay, then now I will save. Then I'll come to view, close my rendering. So now rendering. Now you can see. So I will select all these and then introduce what we call transition repeat. So select weight cursor. And go to geometry and view tile structure. Go to geometry, transition repeat around 2.85. Then goes 3 times, right? 1, 2, 3. Then undo step and then okay. Then I will go now to my plate and then I will add one there. And I will save my structure. So then I will go to the rendering. Now you can see. Now I will define my slabs. So properties. I'll go to define thickness. It's about 6 inches, 0.15, and add. Then I'll select plate cursor, or I can just assign to view. Either can do, then assign. Yes. Then I can go to utilities. I can go to select. See if there are any missing properties. No entity of missing property. Then I can go to materials. All of them are concrete. Okay. Then I will go to specifications. Now I need to add my master slave nodes. I've uploaded videos on why master slave node is very important. Okay, so My master slave node is I already calculated my center. So my center was around my CO center of gravity. COG was about 14.8989 and 11.0868. So and then it was so in each floor now it will be now in each floor. So now I will go to my now hold shift and then N and see the node and the numbers. Then I go to G, then I will rotate it that way. Now my CO was about here. So I will go to the node which is nearest to the CO, which is now it is about here in this slab. So it's now 100 and then 138 and then 176 and then 240. One, two, three, four. So I now add my master slave node. And master slave 100, start with 100. Then digit in ZX its own plane and shift L and just click there inside shift L. You can see now I will add a new master slave. Now first of all I will assign that. Go to that view, side view, and then I'll select node cursor. I'll select all of those nodes. And then specification, I will assign the selected nodes. Yes. Remember, if you want to see, you just click shift and then L. Then I'll go now to my next. It was now 176 and master slave 176. I will be explaining why I will choose CC. So because if you, after you have selected the COG, you know now the COG is not. It's like it will be now a open node because it is nowhere in the beam or the column of the structure. So to avoid other errors, now we choose the node which is nearest to the master, to the center of gravity. Because now the center of gravity is an open node. It is not connected to any member of the structure. So we choose the one which is nearest to avoid that error. So add. Right. I've added the third one. So it's okay. So the second one was 138. So just confirm. Go to B, D, and then create it that way. So it was 138, so we selected this. So just go ahead, select node cast, and then assign to the selected node slaves. And you can see, then we go to 138 now. And master slave. Close first. I will make sure I've done everything right. Edit. It's deleting, yeah, it's okay. Digit in the X then field. So add. Sorry for that. 138. Then ZF and then add. Then I select this node. and then assign. Yes. Go again to 214 now. I must sleep 214. Remember that it is rigid in its own field and has select those. Then let's edit this and check, make sure it's right. Okay. Begin in ZF. Now I'm going to do the review. Then the one in the topmost level, which is nearest to C, center of gravity is around here. So these two, so I'll add another. Must sleep. Yeah. ZX and select. Go to view, go to that view, select cursor, then assign to selected nodes. Then now see the 3D view. Now after that, and hold now Shift L. Just click inside and then Shift L and they disappear. Now hold Shift L, the node will disappear. Now I will go to my support. I will add feed fixed support target. And then I will go to, I will select my support and then I will go to my view, this view, and then I will select these nodes. Then I will assign. Yes. Okay. Then I will close. Now I will go to my root. I will define my roots. I will define first with, just select it and then add, then close and come here, add. Then I will calculate as per that code. Then I will go to expression class B and then building structures. Okay, speed classification category 4, then main building data. Okay, apply main building data. My story height is 2 meters. So this one I will get my building around 28 times 26. So this is now the one is 25. Then design pressure. And people then add and close. Then I select, then I will assign to see all my nodes. Choose hard soil. See, and remember this one is particle, there is no negative. Outside here. So my wall is going to now times my height. My height will be 2.5. That is the height of the floor minus the depth will be 0.45 and then height will be 2.85, which will be 2.45, and then multiply by the unit weight of pattern, which is 20. So 9.5. And then for parapet, I will use a distance of 1. Height will be 1 times height of 1 times 20 times 20, so it's equal to 4. So 9.6. But mainly, if my structure is not designed for earthquakes, because I did not add the bracing for the walls, so I would really wish to avoid this, but I will do it for my viewers. And then for and then I'll go to element weight. Now I have a live load of 4 and in my plates. Then I have, if you use the flow weight method, you can add it and then put your range, but I didn't use that. So I will do this. I select all my external wall. So I would rather wish to move my walls. I'll go to this one. I'll select this. Then I'll go to this structure. I'll go to that view. Then I'll choose my walls only. And go to I have precast, so I choose all the external walls. So these one architecture. My walls are located here, 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 here. Then outside there, here, here. Then I jump 2 beams, then 1, 2, then jump outside. So I will do that. Maybe this should be parapet because it's like a balcony. So slab those then these one you can see. Yes, yeah. So remember, we are starting from the first floor. So the first floor is a classroom, there is no wall, but the ground floor you don't need to go to ground phase already whole here. There's no even breeze in the ground. So it's starting here. You can see this now, one now, and scratch. Right. Then I go to select it of this one, and I go to create. Then I will select, I will choose parallel to Z. Then I will group utilities. I will call them external. Then type is beam. Then okay. Then I will associate. So this has been associated. Now I select all my parapet. So I'll go to select. Structure. You can go back. So first of all, I select my parapet. So I'm going to select that. Select one. And I select all my parapet. So then this will go to creative. Choose, select parallel to X, parallel to Z. Then need to select that one and that one, because you can just select no problem, because the distance here is very small, so no problem. So I just go and create parapet. Then type is beam. Okay. Then assign, associate. Then I'll go to my roof. Structure. I go to my roof. The first part I will select this, that. Then I go to that one. And I select this. Then I will go to select the obvious point. And I go to that one. Go to there, select that, select that. These are my roof. And there, and there, then yeah. And I'm going to that view. Then I will select there. Then I go to utilities, groups. I will click another group, and I call it just groups. Okay, then associate and close. So go to and structure. preview the entire structure. So you can select this. I'm going to select external wall. Then I will assign to the selected. And I go to this. I will select parapet and roof. Then assign to selected. Then I go to this tools. Assign to be. Then I go to my loadings. Add. Then I will define dead load. And I'm not sure if I should define this first before. Right? Not sure. So first of all, we should define very important CSM delete. So add CSM and CSM EQX and EQZ and deadload DL and liveload LL and windload ZX and windload X Z in the direction and tools. Then you and go to CSMIC and tools. So I want to add those to CSMIC. Then now it is in the Z direction, change the direction. Then deadload and self-weight, first add self-weight. So now it should be negative. So now we go to member. So negative 9.6 for the external mode and negative 4 for the parallel depth. And then I go to plate loads. As for my finishes, I will add one. Then I go to live load, add for my floor for plate loads. I will add negative 2. Remember the other one should also be negative. Now in the y direction, right? Plate pressure in there. Or block y. Or block y is okay. Then and I'll go to this, change or edit, then make it negative. Then remember, do y, then change and tools. Then I go to wind, add wind. Tools. maybe this one I should just so maybe the mistake I did was to add the master slave nodes before assigning this. So I should just first of all remove this, delete, then I'll come specification and delete my master slave nodes. But first of all, I should delete all of these. Yes. Yes. Then I will do it really quick. Yes. Yes. So I'll go to specification. Should not assign before. You define window. So I'll go now to loadings. I'll go to read, then I will add. Edit. Just okay. Okay. I'll go to Etabs. And then go to import. And that's crucial. And test. Okay, that was the problem. Then I will add. Now exposure factor. Exposure factor is 1, then add. So remember there was an error, so we delete it. So that you must have the intensity. Because here then assign to you. So you will see where the error is coming. So now my loading. I can just shift those ones up here. Then read. Then this one is direction of x now 1 and negative 1 again. And goes down here. To look now. And read. Now z window of x z and negative 1 and then close. Now I can select see. So now this one I should edit. Remember the window task from range of 10, minimum of 10 now to the 14.25. My story height change. And then also for this edit 10 14.25 change. Then minimum of edit is in the range of 10 to 14.25 change. Also we edit range of 10 14.25 change. And now go to 3D. You can see now the way it is acting. Now if you want to, if you can't view it, you can just enter shift then W. So if this is what you are seeing, just enter shift W. So enter shift W in your keyboard. That is the shortcut for view it. Now I will assign my live load. So I will assign to him because just the plates automatically. Then all of my date load. Self weight I will assign to him. Yes. I go to it. So I will select, I can just select my plate because obviously this one goes to the plates. Plate comes. So if this is just assigned to view. Okay. I select my plates for the negative one, okay? Because now that is the flow finish. So I just select the plates. Yes. Now remember this is the external wall. So trigger. Now we select external wall. Assign to selected views. Assign this. This one. Go to parapet. Then deselect that. Then assign to the selected. Yes. Now I can see. And I'll save my structure. Save. I'll go to that. Now I will go to my loadings. My optimization. I can use BS. Generate and add and close. And I go to my analysis. First of all, you run analysis to check 0 errors. So there are 2 errors. I'll check the errors. Probably sheeted with either nodes So it's related to the wind load because I have already mentioned that before. Alright, so this is the error. So did we define wind before or after? Okay. So what loading? That is why first of all go to my utility, check multiple structures. Structure is one node. There is no often node. One structure with connectivities. So developing entities. This one is okay. That's not going to go there one. Now I'm going to load it. So I should add this after. So if I delete this. Yes. Remember I already mentioned that. So I go to read. First I can delete, define, and ask for this, then delete, then close, render 15.25 and closed, apply, and then I'll go to pressure. Okay. Then I will go to exposure and one, and I'll go to intensity. First of all, I have not added this, so after I generate, I should add first intensity before. That was my error. So be careful. Copy. So apply. Okay. And add. Then exposure factor is 1 and add and close. Then assign to view. Yes. And load and add. Close wind. So wind load Z and then close now. This one I can edit. Call it wind load. Change. Then on. So this one just very simple. All right. So, so the error is very simple because simply add and then add. Don't forget that. Okay. So now 0 errors, 0 1, and then done. So you can see very important to do that. So we did that. We did after diaphragm definition, otherwise okay. So there will be now we can perform our concrete design. So we go to concrete design, choose BS, then define parameters, and I select clear FC and FY, and then okay, then define parameter for beam. I want a cover of my beams. I want a cover of 0.25 and my slab round of 0.2 and then my column I want a cover of 0.35 and go to FC. I will use class 25 to 25,000 for my beams, and my column I will use class that, and my grade of steel I will use 500, simply 500,000, right? Then add and close. Then you can see. Then I'll add my commands. Design beam, add design column, add design slab, add decode, add and then close. So for my clear cover, this for my beams, I'll select all my beams. Parallel to X, parallel to Z, then assign and select and assign this. Now go to clear, I select plates, parallel to X, Z, and I will assign this. I'll go to my columns, parallel to Y, and assign LDS. This one assigned to P. This one I assign to Y. Column and plates. So for my beams and plates, zone assign. And I go to this one again. My plates parallel to X, Z. Then still assign. I go to my columns, beams parallel to Y, then assign, then plates. Then so this one I assign to B because this was the grade of steel. Yes. Design beams assigned to parallel to X, parallel to Z, assign the selected assign. Yes. This one assigned to parallel to Y. Assign to the selected, then assign, then this one assigned to plates. Let X assign, then yes. Then I will save. Then I perform my analysis. If it does not stop this, I will just simply I will just stop it. Stop monitor. Because it will be stuck there forever. So no need to wait. So I touch first. And on the first piece, I load my loadings. I will delete the combination. Delete the combination. Delete the combination. Delete the combination. Yes. Delete the combination. Yes. Then I will again run my analysis. See. Again stuck. So it is image process. You can just do concrete design using RCDC. Alright, or you can just do it using concrete designer. You don't need to do concrete design right now. So just okay, it will not about that. So I just need to task manager. No. Just go to task manager. Then I will end task. Then I will first of all I will not do concrete design here. So I'll delete this command. So we go to I will delete the command. Then I will add my combination. Single yes. Then generic. Okay. Then I will do my analysis. See. No need to do concrete design now. You can do it in concrete design. Okay. Now. And we go to concrete design. So actually, we need to use the concrete designer, and we have RCDC. We can either use this concrete designer, or we can use RCDC. So I prefer RCDC. So we stand by doing our columns. So the reason why I did not want to design for earthquake is because if I add earthquake loads and I have not modeled and actually designed for earthquake, because maybe the structure is too big and it requires a bracing earthquake, that is K bracing for earthquake. Let me see. And so I will add my project columns and I'll add client views and I'll add and use the VS code, and then I will go to first columns, and then I will create a project. So please don't forget to subscribe to my channel. My computer is a bit slow, don't worry. What is it? The real project that is done. So whenever process me to do so, it will save life, of course. Keep so they really do so. I'm not expecting. Here I selected my grade that. So they just 51 500. 500. Or I can use 550 because I designed for other. Right. And then settings. Right, okay. Setting with enforcement setting. When I want to use clouds, 16 plus. And then here. Variable here is now okay. 16. And then my color okay. basic load combination. I group let's say with add quick X, add quick dead live wind X wind Z. So okay. So I can import. Now I can click OK. Then add from my analysis. You can just use this and then say regular. Most of the time is changing. Then OK. So it is doing my analysis. With my column phase, I will have no choice but to exclude algorithm because I have not designed the building for algorithm. Because maybe I should include bracings for my lateral, walls. I should include bracing. That is still bracing for earthquake. So after that, we go to design. Then auto design. Two columns are failing. You can see the effect of earthquake. I was expecting many of them to fail, but to my surprise. So which one is this? So this one I just increase the design section. I'll just increase the section to by 300. Then we design. Then this one should be 400. Okay, you can see the effect of earthquake. Alright. So this one is failing also. So I also will do the same thing. Earthquake is a bit tricky. Yeah, in general, just say tricky. Don't mind. Okay, like that. So my columns are there. So now we can go to and remember the abuse class 30 grade 5 grade of steel 550. So in our country, people that will be the materials. Many people will shun away from constructions, and automatically we as civil engineers will not get jobs, and so we know designing for other will be tricky. All right. So I unlock. No, I won't unlock. I'll go to my design and calculations. My design and calculation. Then I'll get all my calculations. So this is my calculation. I'll just take them somewhere and then I will submit to my consultant, the engineer who is above me. So there's an engineer above me that will now confirm that I did everything right. So that is it. It is what it is. And so I save this. Right. And then print. And then I'll go to my reports again. I'll go to detailed drawing. I'll go to elevation, all my column, and then detailed drawing setting, ribbon map manager, and then prepare to be Y, right? Then shear, so prepare to be Y, and this one I prefer to be that, and then OK. Then foundation data, okay, see depth 600, okay, no need, okay, I've not saved my report, that's why, okay, and then I will, okay, then I will, so that is it. So I'm being caught by surprise. At least this one has passed. So if I was designing for someone in another country, at least I know I will be able to design for earthquake. So I can just need first to save this so that I can save this. I want to save this into DXF. I will save it to my desktop and call it my columns. Then elevation. Then save. So when we were learning engineering, of course, you were told one of the reasons why you won't pursue engineering is because of prestige. Because even if the jobs are lacking, you're an engineer, so it's prestigious, right? All right. It's prestigious to be a structural engineer. So you can just open your file now. So you have to know how to design for earthquake. So this one you can see obviously is the structural drawel, because maybe it means that the structure is not able to hold, so it needs structural drawel. This one, okay. So for me, if there is one with structural drawel, it means I will just, for all of them, I will use structural drawel. And then you can just compile this and build for your time. So now we go to the, we design our beam and then our slab. So I can just save everything as I have done. Then close this. It will take me back right to my G plus 3 floors. I cancel. Yeah. No, yes, is okay, it doesn't matter. It is asking me so should it design a slab or lower first? Alright, and so I'll go here. I'll go here, so put it in, put it in. So this one I learned project is big. And so I'll go to my beam. I will select all the beams that are looking similar. So, right. Okay. So then create. And as I said, I use class 25 as I indicated before. Because, as an engineer, you should know some things by standard. So when you're designing for CSA beams, you cannot design, you cannot put Y16 or T16, right? T16, you should use 16. You cannot use T12. You should use at least 16, as that is the standard. As that is what an experience that will, the engineer will check your work. Will be checking. Make sure you don't do such things. Putting, let's say, T8 for B, that is not acceptable. Also the grade for, if I'm designing for Alpic, I would use at least class 25. So that is it. So reading in progress. Reading in progress. I love it a bit slow. Maybe I should have designed floor by floor for each beam. That is the way I should be doing it. But you can do it for all floors as standard and say, I just use, if I have a drawing for one floor, I'll use the entire roof, the same the same design, the same drawing. So makes your work easier also in one way or the other, because you need to reduce your workload also. And sometimes, so these are my beams. Okay. Actually, I will do it as I'll do each floor. So I don't want this. This is not what I want. So I do each floor. So yes. As you can see, their copy paste is it's not possible. It's grilled out, so that's why. And I need flanged. I need flanged beam. The other thing, I prefer to use Eurocode when it comes to beams, because when I use the BS code, it's giving me torsional reinforcement. I don't want torsional reinforcement. I don't want side face reinforcement in my beams. So I use Eurocode. EN and then beams. And then I just go floor by floor, and then I will create. And then okay. Because if you go floor by floor, now it will be possible to put the depth of your slab, which is you are designing all your beams as flanged. So please support my channel. It takes me a lot of effort to create this video, and you can download Staadpro from the official website of Staadpro. So I want to now Slab. Now you can see I can copy paste. I add 50. Okay, 150. Now my depth of slab, and of course all my beams will be flanged. Copy and then paste. Now if it is grilled out, it's because it's selected multiple floors, right? Don't worry. I need to give no torsion at 0.1. Then I want to select all to be darkened, all my wings to be flying, my class to be 25 flat, my state grid to be 550, because now the problem is the CS weak. Maybe just even for 60, it doesn't matter. Columns are the ones which are tricky. Those who know the trick of designing them, maybe. Say minimum is that, maximum is 32. That is by standard. My spacing I want it to be at least maybe 200, right? Okay, 200. I don't decide reinforcement, but it's okay. Then okay. Settings, and go to basic load cases and include all the other quicks. X, other quick Z, and also as an engineer you should be very careful. It is better to save lives, and it is not, you don't want to be responsible for loss of lives like the guy in the Titanic. You saw the way he was scared when he saw what was happening to people, all the blood in his hands. So as an engineer you have to be ethical. So you don't need just to look for money. Okay, so I look for my analysis and then okay. And then I go to design, then how to design. You can just click that small play and just design. So if they fail, it's because, as I said, the quick is tricky to design in a place where you must design for other quick. Very tricky. That is why we put something which is difficult. That is why we say in Kenya. And of course, mostly in Kenya we don't communicate each other in Swahili. Most people don't speak English. And I wish it could be that even for you. You could be speaking another language, Swahili, because I understand Swahili better than English. So I don't know which one is failing here. Probably is one beam, so you can just design and check which beam is failing. You can see it's beam 29. So which one is it? This beam. So I can just add the text. And then design. Okay, shear reinforcement. Is failing in shear. Okay, so I know what to do. If they are failing in shear, I just unlock. I go back to my setting, general setting, and this one I just leave it at 100. Don't have to stress, or just 150. Don't need to stress myself because it is failing in shear. So basically means the spacing should change, the spacing of shear reinforcement down. Now this time I click that. The good thing about RCDC is because it generates drawings for you. But at the end of the day, what you are going to present is your drawing, not your calculations and not your model. So because it generates drawings for you, it makes your work like 60%, like almost 80% easier. So you are always almost through your work. Okay. So I was saying that I wish I could be speaking in Swahili, so it would be easier for me to communicate easily with you. So this one I will design. I don't know why it's failing. I should just let me check. Still share. Okay, share. So just put 100. Okay. Put 100. Put 100. PF. Clear cover. We should just change. T29 600. Then design. So they have passed now and accept. And also the same for this design. Probably it is one of them is failing, so we don't know which. So what I'm doing is just click design and tell me which one is failing precisely. So I increase the depth. Probably I say 550. And then probably I went too far. So 600, obviously 600. And then cool. If I change the grade of steel, let's see. So I'll have to redo the process, change it just minimum 100. This earthquake, and I say this earthquake. Okay. Earthquake is very tricky. It's failing in shear. Then I will run it. So I have a lot of good content for you guys. Actually, I would just request you humbly, please subscribe. Don't just view, subscribe. Remember, let's support each other. That's the way it should be. Because when someone needs you to support him, you should just accept and support them. And me, I need you to support. So, okay, I change my to be 600. Then design. Also here, I don't know if now it will pass. How many have to? Okay, now this group. Let me check which is very precisely 45. Yeah, on the same place. I put 600. If it continues to fail, I will increase the depth. And increase the depth also to 50. Then we design. Maybe 225. Here's in here, T47. Combination number 1. Now I say this is my issue with earthquake. Can give me a lot of trouble. So it is very easy. torsion. It's very in torsion, so I should add side face reinforcement. We put 300 by 600. B47. No. So we were designing 47, 45, 200, then 450. Then divide 2. Yeah, it was 12. I'm adding the wrong beam, 600. That is why. Even I don't need this. I don't need to change here. So simply so we're going to learn very much here. 250. 250. Move like not even share reinforcement there. So now it has passed. I was changing the wrong beam. So then now okay. Now all of them are passed. Now when you get your report, the calculations there, then beam size change here, you can see. Then you can just print this, then you can go and then print, and then save. And then you save any beam change, then save, then you can go on. The most important, the one that I like most is this elevation of section. That is the one I love most. Calculations, then ray setting, mark Y, shear Y, or just T, no problem. And then okay. Yeah, T. For columns and beam we use T. No, wait, first wait. Then don't forget cross section, very important. So you can see I have T20s, the T20 and of course I don't have side face reinforcement. That is why I avoided just need to say I avoided BS code. So here in Kenya we can use BS or Euro code. Maybe sometimes we prefer Euro code, some other prefer BS code, but for them here we force them to Euro code plus, because I don't want side face reinforcement. Then I save it as drawing. Save. Then of course can go and open and find. So as you can see, all my names are here, and see. And I presented another video about how you can detail. So you should just go and check my videos in my channel right here. So finally I will go for Slab. Remember I have staircase here, okay? Before I go to Slab and staircase, and just add here a lot of you can just do, but already we designed this column to be bigger in size than the rest, because So the design will still be okay, but remember to add here a load of 11, 11, 11, and then to the, that is to the 22, 22 for the 22 kilonewtons per meter for the weight of the slab of the stairs. Okay, and for the roof you can add 11 because now remember stairs the weight looks like that. So this one will be sharing, but this one will be holding the entire weight. So it will be 22, 22, and then because let's say it's a two-way slab, it's a two-way stairs. It's a two-way stairs. I think I am doing over stairs here. Stairs here. Okay, can't see, but if it's a two-way slab, the stairs. Let me show you. Let me just open. Is there anything? I'll show you in the slab. So we'll do to RCDC. But it will still pass because obviously you say the column for your stairs and the water tank should be bigger. So go to slab, client, view, free. Then I was so concerned about earthquake that I forgot about stairs. So slab, even these are just before, then I can use it for the rest of the floor. Now for the sake of the footings, we just add the loading for the stairs. Then we do analysis. Then we will not design column or we will not repeat for these others, but we will. So my imposed load was if you calculate the weight of the slab, you can go to my calculator and just use the Autocad calculator. Just calculator. Remember, you already know how to do this point. 1.5, that is the depth multiplied by the strength of concrete, which is 25. You will get the self weight. Get self weight 0.075, and then we add 2 for finishes and for others. So if there is any partition in the future, just add 2.5. Live post load was 4. Then our thickness was 150. And I'll copy this. Remember, if you did unit floors, unit level, not able to paste. So then paste. Then go to setting, design parameter. Okay, so I'm gonna use class 25. I'm gonna use 500. Make a look for 20, and then here spacing is 200. Then okay, minimum support. And design. So I'm saying for the sake, before we design footing, I just I just do my so I do not need my rebar, so that's why it's giving me all these D8, and then it's not something that I can present. So I go to settings, design parameters. My preferred rebar size 8. I design in terms of rebar. Minimum spacing is 200. And then, okay. And remember, for those who do it manually, they often design only for the critical slab, which is this slab, right? The biggest slab. So, and they use for the rest. So, I will just check for the critical slab, and then I will use the same design for all my slabs. So my critical slab is, if I'm not wrong, it's that one, right? So you can see the spacing is 15. Okay. So I will use the same design for all. So I can just do, unlock, yes. And then I'll go to setting, then parameter, and put here to 15. I put here. I can just say 200. Goes to 15, goes to 200, then min max 200. And I will use the same design for all my slabs. And then you can go to my reports. You can generate calculations. You can get my stairs section. Stairs. So you can see my stairs. So as I was saying, if it is one way, it means just going that. But my stairs is two, it means there's no stairs going that. So it means, you have only one stairs, and then slab one stair, then slab stairs. So it will be 11 to 12, and then just going up. So it's 8 to 11, 11, then 20. That's what I'm trying to say. I don't need the calculation. So most people actually might. Okay. Let me show you. So as you can see, this one here is cut out. So just say group. This is the most one I like most. I have a really that is to do this decline. Right? And you can see the tree is perfect. Almost perfect. So the only editing we do is very and that's it. And that's it. add and this for the staircase and check this and control select that. Then assign to select it. Yes. Then confirm. Confirm. Then I will select this and then select that, select that, select that. Select that, this is 3. Assign to select that is select that, select that, and select assign to select then use. I'm not going to repeat, but if it was me, myself, I'm not going to create everything. But just want to show you I forgot to write there. So worried about and I'm done with analysis. So 0 error 1 is okay. Then I'll go to this. Then I'm going to design my building now finally. Putting river there and I will increase it. Add footing, then I can go to settings, and check this branch. No, not I can check slide, check overturning. Consider overturning, check that. And then I can go that, and I want this mine to be 100, considering your earthquake. But here in Kenya, obviously, just do 50 because no new buildings will become erected, and we don't want that because we will not have jobs, So it is as that. So again, where did I missed? Over the table, my depth will be here around, let's say 2 meters. Water table should be far below, like 10 meters, or very far below, and this maximum pressure. Okay. Minimum depth. My minimum depth can be. Okay. You go to setting reinforcement. Minimum I will use 12. Maximum still I will use 16 if need be because of earthquake. Then and then I can place OK. And then the other thing you can do is this cases earthquake X, earthquake Z, dead load, live load, wind load X, wind load Z, then select, and then OK. Apply from the analysis, then OK. And then sizing factor definitely is one from regular structure. Okay. Sizing factor is basically, remember there is an ultimate load and there is factored load. So sizing is just one, the unfactored load case, alright? Then learn the analysis. I've forgotten one important thing, but it's okay. I explained further in another video, which is just on footing. So you just watch that video of how you should just do it precisely, because you should group your columns to have uniformity, because you don't need to confuse those who are on the site by having very many types of bases. You need to have at least minimum 5 or at least less than that. But you have like 20 bases, then there is confusion. Because most likely they will not follow. They will not follow your drawing because they are human beings. Yeah. And they make their assumptions also on site. So you need to have like something which is, and now you can see these bases are varying. So, yeah. So for this, maybe you can do combined footing. And you could just go and design it in another software differently, like in let's say don't know, you can just go in the advanced. So you have the footing, then you can go to your report, get your calculations, then go to your drawing, and then section, and then okay. So you can see I have so many bases. So you will watch my other video which I did just for foundation using RCDC. So you know how you do precisely the right way. You can see I have my structural dowels here, okay? So just to hold the compression. Okay, guys, please don't forget to subscribe. Thank you.